Okay, let's dive in. Few RC cars really stick in your mind, like the Tamiya Frog, right, from
Oh,
'84.
absolutely legendary. That 110 scale buggy, the ORV chassis, it was groundbreaking stuff.
But even legends have their weak spots, and the Frog had a pretty famous one.
Yeah, it really good. The stock differential, that was its Achilles heel for sure.
What was wrong with it exactly?
Well, it was made of nylon and pot metal.
Yeah.
You know, cheap alloy, kind of brittle.
Okay. Not exactly tough stuff.
Not at all. And the gearbox side plates, soft aluminum, so under load, like if you put in a hotter motor or took big jumps, even just bigger tires.
Let me guess, things started to bend.
Exactly. The plates would flex, the gears would lose their mesh, and then you'd hear it.
The click of death.
That's the one, that awful clicking right before the gears just strip themselves bare. And the original Hicks drive shafts weren't much better, honestly.
I definitely remember that sound from my own RC days. Always a bad sign. So you'd think this flaw might have, I don't know, hurt the Frog's reputation?
You would think. But it was actually the opposite. It, created this massive demand for better parts, for hop-ups.
So the weakness actually fueled an industry.
Yeah. A whole aftermarket scene grew up around fixing that Tamiya diff. It's kind of fascinating how a problem can spark innovation.
And that's our mission today, right? We're looking at two key solutions. The old school Thorp dirt burners diff and the modern MIP Super Ball diff.
Yeah. Comparing how they tackled the same problem decades apart. Different engineering ideas.
Cool. So let's start back in the 80s. Who stepped up first? Thorp Manufacturing. Dirt burners.
That's them. Sorp. They were like the name in RC aftermarket back then. Real powerhouse.
Known for quality stuff.
Oh, yeah. Precision parts, all made in USA. Their whole thing was basically strength.
And their answer for the Frog diff?
Was a Thorp number 4500 ball differential. Basically a direct swap, but completely bulletproof.
How so? What was it made of?
All metal. We're talking hardened steel pressure discs, steel diff balls, usually 332-inch, a metal main gear, plus a really tough thrust bearing setup you could actually tune.
Wow. Okay, so no more pot metal or flexing plates.
None. Thorp's thinking was simple. Metal is better. Just brute force strength to fix the problem.
Any downsides to that? Weight, maybe?
Yeah, potentially. It was strong, but maybe not the most sophisticated solution by today's standards.
Yeah.
But back then, it worked.
And finding one now?
Oh, it's tough. The Thorp 4500 is like a holy grail for collectors. Super rare. You'll easily see them go for over $100, sometimes way more.
A real piece of RC history, then. Okay, so that's Thorp brute strength, all metal. Fast forward a few decades, how does MIP approach this? Moore's ideal products.
Right, MIP. Founded by Eustace Moore Jr. himself, a top RC racer, also made in USA, but known for, let's say, more refined engineering.
So a different philosophy.
Definitely. Their frog solution is the MIP number 1622 seat Super Ball diff, and they call it a solution, over 30 years in the making.
Okay, sounds serious. How's it different from the Thorp?
Well, it's designed for modern power, brushless motors, LiPo batteries, stuff that puts out way more torque, so it uses a mix of materials.
Not just all steel.
No. The main gear is actually precision machine nylon.
Nylon?
Right.
Really? Isn't that what failed in the original?
But this is different. High quality precision machine nylon. It's lighter, so less rotating mass, better acceleration, but the parts taking the direct load, the drive rings, those are hardened steel.
Okay, interesting. Hybrid design. What else?
A big innovation is the thrust assembly. It uses a rebuildable machined aluminum T-nut, way, way stronger and more reliable than the older thrust washers and screw setups.
And they address the flexing gearbox, too.
They do. The MIP kit includes high-quality flange ball bearings. These support the diff properly and help stiffen the whole gearbox case, stopping that flex.
So it's more than just the differential itself. It's like a whole drivetrain upgrade package.
Yeah, exactly. It's a systemic fix. And yeah, you need other parts to make it work properly in an original or rere frog specifically. Better universal shafts like Tamiya's own #5390 set. It assumes you're running modern power.
Right. So if you put it all together, Thorp's 80s approach was make it stronger with metal. MIP's modern approach is more use the best material for each job, optimize everything.
That sums it up perfectly. Thorp overbuilding for strength. MIP optimization for performance and durability with modern tech.
So they were kind of competitors tackling the same weak spot. Did their paths ever cross in unexpected ways?
Actually, yeah. It's a cool bit of RC history. While they competed on drivetrain parts, much later on, MIP actually became the exclusive maker of the legendary MIP Thorp Hex driver tools.
No way. So they ended up collaborating on tools.
Yeah. Shows kind of mutual respect in the community,
Yeah.
not just rivalry.
That's pretty cool. Okay, so we've got these two fantastic but very different solutions. The big question for anyone with a frog, which one is actually better?
And, well, the answer really truly depends on what you want to do with your frog. There's no single best.
How so?
If you're a vintage purist, a collector, you want that period-correct feel, maybe for a shelf queen or running an old stock motor.
Then the Thorp is the way to go.
Absolutely. The Thorp #4500 is the historical champ. It is 1980s hop-up culture. It's the authentic vintage upgrade.
But if you want to actually drive the frog hard today with like a modern brushless system and lipo packs,
Then honestly, the MIP #16210 is hands down the superior choice, no question.
why specifically?
It's built for that power. It's more durable in that context. The lighter gear helps performance. The better bearings reduce drag, and you can still get parts for it. It's serviceable.
Right, availability and rebuildability matter if you're actually running it.
For sure. The Thorp is amazing history. The MIP is amazing modern performance engineering.
So two engineering marvels, really. Each a product of its time, solving that original Tamiya weak spot using the best tech they had available.
Exactly. Which leads us back to the core question for you and your frog project.
What's it going to be?
Is it destined to be a museum piece or a modern weapon?